Assalamu alaikum warahmatullah. Today we are going to discuss Wheatstone bridge. We will only discuss the balanced condition. The unbalanced Wheatstone bridge we will take up in the next session. So let's start. For example, if we have 5 resistances and they are arranged in this way. So we have R1, R2, R3, R4, and there is one more resistor, R5. This kind of pattern of resistances is known as Wheatstone bridge. Let's connect it to a power supply, V volts. Now this Wheatstone bridge, we have different conditions that we will derive, but how to find the net resistance of this circuit and how to find the current through different resistors. So on the superficial, if we just superficially try to analyze the circuit, we understand that this current here will get distributed between R1, R3. But again, these R1 and R3 are not in parallel. Why? They will only be in, these two will only be in parallel if the potential of this point, maybe point A, or we can say X, and this point Y, that's same. But we know since there is a resistor in between and there is a possibility that some current will flow through this, in that case the potential between this X and this maybe Y, that will not be same. When that is not same, so these two are not in parallel. Now let's take R1 and R2. Since the current flowing through R1, it will get distributed. As a part of this current will flow through R2 and rest through R5. Or maybe there is a possibility that the part of the current flowing towards the node right here, that will get added to the current flowing through R5 towards this node, and both will get added up and constitute the current through R2. So that's the way. Now we only have to discuss the balanced condition of this configuration. That's called as Wheatstone bridge. Now the Wheatstone bridge is simply a configuration. In Wheatstone bridge, we have two conditions. One is if this is balanced and if this is unbalanced. So as far as your board exams are concerned, this balanced part is a must, and you have to understand this part. But for NEET, again, balanced is sufficient. In JEE main, the balanced part will take care of that. But as far as JEE advanced is concerned, there are numerous times when they have asked questions on unbalanced Wheatstone bridge. So this part we will do in our next session. Right now, let's take care of the balanced Wheatstone bridge. Now the condition for the Wheatstone bridge, the condition when this bridge is said to be balanced is when the current through R5, current through this R5, maybe I call it I5, this will be 0. Whenever the current through this limb, that is connecting two different, this is behaving like a bridge between these two sides of this circuit. So this bridge, the current through this bridging resistor, when this current is 0, this configuration is said to be in a balanced condition. So let's try to analyze. So I will make quickly, we can go through a couple of points. Point number 1. Now we have to understand there is a resistor. It is not a pure conductor. If it were a pure conductor, we would immediately say the potential at this point and this point are same, but still there might be some current flowing through this conductor. If we replace this resistor by a conductor, that we actually took up in our last lecture, and we can that in that case it will be a very easy question. But when this is a resistor, and in case some current is flowing through this, the potential here and here will be different. There will be some potential difference across this. Only then can the current flow. Now, the balanced condition, what is the condition for this bridge to be balanced? Current through this bridging resistor, it should be equal to 0. So there is nothing like a term like a current through BR. So that's what I am writing right now, so that we understand this concept. This is kind of a bridging resistor. When current through this is 0, there will be a condition. When this current is 0, at that moment, if this point is an X potential and there is 0 current through this, so the potential through across this resistor on the other side, what will be the potential at this point? It will again be X. Why? Because there is no drop across this. And why? Because there is no current. So drop across this, whether it is plus minus towards this towards the down point, towards this point, whether there is a rise in potential or a drop in potential, but the potential difference across this will be equal to I, the current flowing, and multiplied by the R5, that's resistance value. Now, since the balanced condition necessitates that this I5 is equal to 0, so यहाँ से तो current है नहीं, there is no current flowing through this. It means if this point is at X potential, this will again be at X potential. If we are applying voltage V, this means this is 0, 0, this is V, this is V. Fine. Now there is a condition like this. Now this point is at X, this is again at X. Let's try to find it out. What will be the current through this R1? Actually, since no current is flowing through this lane, all the current flowing through R1 will directly go to the current through R2. So I can write this current is equal to this current. I would say I1 and this is I2. So I can write I1 equals to I2. Fine. Why? Because any amount of current flowing through R1 will flow through R2. And no part of that current will flow through R5. Because that's the condition. So this is only possible when I5 is equal to 0. So this is the condition. I5 is equal to 0. Now if I1 equal to I2, I can write this I1, this current flowing, equal to potential difference divided by resistance. Simple Ohm's law. So the potential, what is the potential difference across R1? Higher potential is V. This is lower potential X. So I can write V minus X by R1. And what is the value of this R2? I2, sorry. It is X minus 0 divided by R2. So I would write this V minus X by R1, that's I1 equal to I2. So value of I2 will be potential difference, that's X minus 0 by R2. So this we can call as equation number 1, simply. There is no rocket science in this, very easy equation. Now let's take this R3 and R4. No current is flowing through this R5. The current flowing through R3 will be equal to current flowing through R4. So I can say I3 will be equal to I4. Why? Because I5 is equal to 0. Again, same condition. This is the condition. So I3, I can write it down. It will be equal to V minus X by R3 equal to I4 will be X minus 0 over R4. This is the second equation. Now we got these two equations, but they are actually conditional equations. What I mean by conditional equations, these equations are true only when the current through R5 is 0. What if the current through R5 is not 0? That we will take up in the unbalanced part. Now, very simple equations. We can divide these two equations. Now try to, you can say, you can do it at your home. It's very simple. V minus X over R1 divided by V minus X over R3. V minus X and V minus X gets cancelled. So this I can cut like this. So I am left with 1 by R1 divided by 1 by R3. So R3 will go over there. So R3 by R1 equals to X minus 0 gone. So this will be R4 over R2. So this is the equation we got. Now let's cross multiply it. So we got R1, R4 equal to R2, R3. Very important. It means, now let's try to understand this. When the current through R5 is 0, this relation is true. It means R3 or R1 will be equal to R4 or R2. It's like this. R3 or R1 will be equal to R4 or R2. Inverse is also fine. That's R1 over R3 will be equal to R2 over R4. This we can also write if we cross multiply it like this. R1, R4 equal to R2, R3. Now I have a couple of points to can see here. I will share with you. Whenever we will apply this formula, or whenever we have to recognize a Wheatstone bridge, you have a choice. You can use this formula or you can use this one. But what I have experienced in my life, the best way to recognize a Wheatstone bridge, especially in the questions asked by JEE, this one is much, you can say, better than this one. We will discuss about the concept of this equation, but right now let's finalize this equation. And how to remember this equation? Always the Wheatstone bridge opposite resistances, product of opposite resistance should be equal. It's like this. R1, R4 should be equal to R2, R3. So this bridge has 4 resistances. These two are opposite and these two are opposite. The R1, R4, the product of these two resistances, if that product is equal to R2, R3, then the Wheatstone bridge is said to be balanced. Two corollaries from this. One, if the current through R5 is 0, then R1, R4 will be equal to R3, R2. Or its inverse. So let's write it somewhere. Let's write it down here. Point number 1. If I5 equals to 0. अगर हमें पहले से ही पता है, if we know this, that the current through this R5 is 0, how we can know it? We can use some device at times or whatever. So we know the current through this is 0. If this is 0, then opposite product, the product of the opposite resistances, that is R1, R4, will be equal to R2, R3. So this necessitates this. Second, its inverse. If R1, R4 equals to R2, R3, if this I5 equal to 0, it is not given there. But what is given? That the product of these opposite resistances, that R1, R4 is equal to R2, R3. If this is given, it necessitates that I5 will be equal to 0. Well, that's the same thing actually. Fine. So this is a Wheatstone bridge, and it is said to be balanced when the current through this bridging resistor, the R5, this is 0. R5 means we are just designating this resistor. We are giving it a name R5. Otherwise, it can be any value, 10 ohms, 1 ohm, whatever. So it is said to be balanced when the current through it is 0. Point number 1. Point number 2. Whenever that current is 0, we get this relation. So we have two options. Either it should be given in the question that this current is 0. If it is given, automatically we will conclude this, that this product of these opposite resistances, these two, is equal to product of these two opposite resistances. Point number 1. Second, if it is not given that current through this is 0, but we discover that this equation stands true for this circuit, means we get a kind of, if we calculate it and we see that the product of these two resistances in the circuit, that is equal to product of these two, so it will automatically necessitate that current through I5 will be 0. Very simple. So this is called as a Wheatstone bridge. Now remember point number 1, how we are applying the potential difference at two ends. Then there is a bridging resistor, and then there are 4 resistances. This pattern is known as Wheatstone bridge. Let's try 2 questions. Question number 1. Okay, let's start with this one.